Everyone, today my team and me gonna present video on the light dependent resistors. The light dependent resistors works on the basic principle that as the luminous intensity increases, the resistance of the LDR decreases. As you can see here, as a bright sunlight, which is equivalent to the flash or the blink of the LED, the resistance increases. So that the voltage is constant, V is equal to IR, the current increases in the circuit. So that we can see the spikes on the graph.
About Arduino, LDR with Arduino, in which we have three type of main equipments: breadboard, Uno, and BNS cable. And there are three type of another wires. These are male wire and resistors and light sensor. So first of all, we connect the yellow wire here with the 5 volt and here positive, and the red wire is connected with the A0 and here there, and the blue wire is connected to the ground. Then we connected the one wire of resistor with the ground wire and one wire with the A0, and then we connected the light sensor with the one wire with the 5 volt and one with red wire. Then we can check it on, then we can go on tool and check it on series plotter. Then we see that the graph is showing. If we touch our finger, then show the difference here. Yeah. Then if we use the flash, then it also show the difference. And if we remove, then it's so like that, and then if we put less light, then it's so like.
Initially, I have set the frequency to 1 Hz in the function generator. Now we can observe the slow blinking of the LED. Here we have connected 1 kilo ohm resistor. We can also observe the graph and its structure in the serial plotter. Later, I am changing the frequency to 3 Hz. Now we see the fast blinking of LED and how the structure of the graph varied from the previous one. It looks like compressed from both sides. Now I am switching to 5 Hz. Here we observe very fast blinking of LED and graph that looks like more compressed from either sides. Here we can observe that how the graph is changing. Now I am doing the same thing using 100 ohm resistor. Firstly, I have set the frequency at 1 Hz. Here we see the slow blinking of LED like this. And then if we observe the graph in the serial plotter, it is looking like this, little wider. And I am switching the frequency to 3 Hz. And I am observing the LED light. It's blinking little fast. And if I observe the graph, it's looking like little compressed from both sides. I'm switching the frequency to 5 Hz. The LED is blinking too fast and the graph is looking like this, like little more compressed.
Now the frequency is set to the 1 Hz. You can see the blinking of LED here. It is connected by the alligator pins and it is connected to the Arduino board. And we can see the graph, it's a normal graph. And here you can also observe it on the oscilloscope. And now if we use this flashlight, as the light intensity increases, the resistance of the LDR decreases, so that we can observe a spike in the graph. You can see there the graph has a spike over here, and if we you can also observe that in the oscilloscope, the spikes. As a flashlight is on, the spikes are observed. We had connected 100 kilo ohm resistance here, and we can see the graph here, and same in the oscilloscope. Yeah, now we will use the flashlight, mobile flash, and as we hold it on the LDR circuit over here, we can see the spike, the graph rises up here, and if you remove it, the graph comes down. and we can observe it in the graph. We can see that clearly the flash is on the LDR, the graph comes up, and we can also observe it in the oscilloscope here. As flash on, the spikes are high, flash off, the spikes are not there. So now the application of LDR mainly include alarm clocks, street lights, light intensity meters, and burglar alarm system. Thank you.